In this lesson video for day 4.1, we will be talking about ratios and proportions. And some of this will be a review of previous content, either from last semester in geometry or maybe a previous course. But today, when we talk about ratio and proportions, we need to first understand what a ratio is. A ratio is a comparison of two or more quantities or two or more sets of values, and it can be represented as a fraction, like you see here, A over B, or you can use the words A to B, or instead of using the word to, T-O, you could just write it with a colon, A to B, like that. But it is important that we always remember we want to simplify whenever possible. Okay? So as we work through some of our examples here, we will be given some sets of values or quantities to compare. On this first example, it says, what is the ratio of sophomores to seniors? Well, there are 310 sophomores and 302 seniors. So I could write that as the ratio 310 to 302. However, I want to reduce that, and we need to reduce this the same way we would reduce it as if it were a fraction. We want to divide both sides of this ratio by the greatest common factor, right? Greatest common divisor. Okay, and sometimes it's harder to see those, so if you recognize that you can just maybe divide by 2, we start with that. So if I divide 310 by 2, I get 155. And if I get 302 divided by 2, I get 151. And so if I write that, 155 to 151, that is as simple as I can get it. Neither of those numbers have any other common factors. You can't divide by any other even number, because these are both odd. You can't divide by 5s or 3 or 7 or any of those numbers, and so it doesn't take long to realize that is in simplest form. Okay? Then it asks in the next part, what is the ratio of juniors to seniors? All right, so as we look at this, the number of juniors was 298, and the number of seniors was still 302. You recognize there that we can divide both of those by 2, so that ratio simplifies to 149 to 151, and that will not reduce either, so that's your simplest form. And lastly, part C kind of asks a strange question. It says to write the ratio that shows the comparison of sophomores to juniors to seniors, a 3-part ratio. So we can take our numbers for sophomores, juniors, and seniors, and we could write it out long ways like this, 310 to 298 to 302. And that is a ratio of sophomores to juniors to seniors. But remember, we reduced all those numbers by 2. So I'm really going to change that to 155 to 149 to 151. And it must follow that order. Sophomores first, juniors, then seniors. The order of your sentence tells you which number goes in which spot as you write ratios. But this last example, part C, helps us to get an example of something called an extended ratio. Excuse me. An extended ratio is a comparison of 3 or more quantities, and we would write this using a colon like this, A to B to C. And that's how you'd write an extended ratio. And we will use extended ratios in problems like these examples. So number 2, they tell us that the ratio of the angles of a triangle, meaning the angle measures in degrees, is 3 to 4 to 8. Now this does not mean that the angle measures are 3, 4, and 8, because those would not add up. 3 degrees, 4 degrees, and 8 degrees would not make a triangle because the numbers are too small. However, we can understand that really the angle measures could be 3x to 4x to 8x, where x is that common factor that we simplify our ratio by to get down to a simplified 3 to 4 to 8. And if you understand that the ratio really could be 3x, 4x to 8x, then you can understand a little bit more about these angle measures in a triangle. Now you need to remember that all 3 angles of a triangle must add up to 180 degrees. That allows me to write this equation, 3x plus 4x plus 8x equals 180 degrees. And as we look at that, as we look at this equation, all we need to do now is combine like terms. 3 plus 4 plus 8 combines to a total of 15x equals 180. And then we can divide by 15. And we get that x is 12. Now, we do all that to be able to answer the question that they request. Find the measure of the largest angle, and then classify the triangle by its angle measures. This part of the ratio represents the largest angle because it's the largest factor. And so all I have to do to find the largest angle measure is do 8 times 12. And 8 times 12 is 96 degrees. There's already a degree symbol there, but we don't need that. Now, as you look at this, the classification by angle measures must be either acute, where all the angles are less than 90, or right, where there's one right angle, one angle equal to 90, or obtuse if there's one angle greater than 90. And this largest angle measure is greater than 90, so this is an obtuse triangle. Okay? As you continue on in the next example, though, again, they give you an extended ratio, but the ratio this time is of the sides of a triangle. So I'm not going to use the total 180 degrees because I'm comparing sides, not angle measures, which is why they give you this next statement. It says the perimeter is 126. Well, again, perimeter means the sum of all the sides. So this extended ratio, which I could kind of rewrite as 4x to 8x to 9x, gives me the equation then, 4x plus 8x plus 9x equals the total for the perimeter in this case, 126. And again, we can combine our like terms. 4 plus 8 plus 9 is 21x. And then if I divide both sides by 21, I get that x equals 6. Then again, I can find the length, in this case, of the shortest side, which would be this 4x expression. 4 times that x value of 6 equals 24. And we do have a unit of measure, feet, so the shortest side is 24 feet. And this example asks us to classify by its side lengths. The side length classifications for a triangle include isosceles, scalene, or equilateral. And those are based on the congruence of sides. Now, we could have actually classified without doing any of the rest of this work. If you look at the ratio, 4 to 8 to 9, that tells you all three sides are different from each other. There are different side lengths. There are no congruent sides, which means that this triangle is scalene. Okay? Let's continue moving along. In this next example, example 4 is really a combination of the two examples we just did. The first sentence says the ratio of the angles of a triangle is 1 to 2 to 3. Then it gives you another ratio. The ratio of the sides of that same triangle is 10 to 17 to 20. The perimeter of the triangle is 235 inches. Solve for all sides and angles and then classify in both categories. So I've split this up for you where we can look at angles separate from sides. The angles classification is going to use this ratio. And the sides classification will use this ratio. And so really this is two problems in one. What I want you to do is pause the video and try each of these using the last two examples as your guide. If you're stuck and want to see how I've done it, you can click play and just observe that and pause and copy down as you can. Otherwise, try this example on your own. When you've reached your answers, continue to click play, and you will see what answers we get. All right, for the angle classifications, when you set up your equation 1x plus 2x plus 3x equals 180 for the total of the angle measures, you get 6x equals 180, and dividing by 6 gives you x equals 30. So when I plug that in for the smallest angle, we get 30 degrees. For the middle angle, we get 60 degrees, and the largest angle is 90 degrees. That 90-degree angle makes this a right triangle. And then as we move over to classify by sides, the equation 10x plus 17x plus 20x should equal 235, the perimeter of the triangle, giving us 47x equals 235. And then we divide both sides by 47, and x is 5. And then when I plug that back in for those side length expressions, 10x, 17x, and 20x, the shortest side is 50 inches, the middle side is 85 inches, and the largest side is 100 inches. Again, the ratio 10 to 17 to 20 shows us that all three sides are different, which makes this scalene. All right, as we continue to move forward, all right, now we're talking about something called proportions. A proportion is simply an equation that states two ratios are equal. Okay, so it would be written as this. A over B must equal C over D, just using A, B, C, and D to represent the different parts of a proportion. In any proportion, and this is a little bit extra here, in any proportion, you can cross multiply to solve for a value, to solve for x. That is based on what we call the cross product property, which simply states that the cross product, like the numerator of one ratio times the denominator of the other one, so in this case A times D, that's the cross product, must equal the other cross product. In this case, that would be B times C. Since cross products must be equal in a proportion, we can cross multiply to solve for x, and we can also use cross products to determine whether two ratios are in fact proportional. We'll get to that in a little bit. So to solve for x in these proportions, you'll notice these are all proportions. We have two equal ratios in each one. We simply cross multiply. Okay, so for example, A here, we cross multiply. 4 times 77 is 308. And 11 times x is written as 11x. Now we simply divide by 11 on both sides here. We should get that x is 28. Okay? But when we move over to the next example, B, you'll notice that it looks a little more complicated. We have this expression in the bottom of that ratio. When we cross multiply, I have to take all of that expression times 2. So you need to understand that we must write it with parentheses so that you remember to distribute in that cross product. The other cross product is just 3 times 15, which is 45. Now the next step is to distribute. 2 times x is 2x. 2 times 4 is 8. 45. Then subtract 8 from both sides. So 2x on the left equals 37 on the right. And then we divide by 2, and we do get a decimal this time, and that's okay. We didn't do anything wrong. It's just sometimes you get decimal values. 37 divided by 2 is 18.5. Okay? And as we continue to move on, it continues to get a little more complicated. This time there are two quantities that have something other than just x here. Both these denominators are considered binomials. They have more than one term. So when we cross multiply, we need to distribute in both cross products. 3 times the x minus 2, parentheses, has to equal 4 times the x plus 3, parentheses. And we distribute on both sides, giving us 3x minus 6 equals 4x plus 12. And we solve this equation first by subtracting 3x from both sides, giving us negative 6 equals just 1x or x plus 12. and then we subtract 12 from both sides, we get negative 18. And sometimes you do get negative values for x. So x equals negative 18 would be that answer. And you could plug back in any of these to check your work to see if it's right. Okay, finally part D here, we're going to cross multiply again. This time x minus 5 will go in parentheses so that we distribute there. And in the other cross product, it's just 2 times 2x. We don't really need to distribute anything there. It's just a single term times 2, which simplifies to 4x. On the left, however, when we distribute, you get 6x minus 30. And even though 6x is a bigger term than 4x, we need to subtract this 6x, sorry, I wrote the wrong one, subtract 6x from both sides so that I don't end up with just nothing left on one side. We get negative 30 then equals negative 2x, and dividing by that negative 2 will cancel the negatives. So we get a positive answer of 15. Okay, so that's how we can cross multiply to help us solve proportions. All right, and we have just a little bit left in this lesson. As you look at these next examples, though, the directions say to decide if the following are proportional or not. So we're getting a yes or no answer. And it tells you we can check what number was used to multiply. And I'm going to do that for the first one, but for a couple others, I'm going to show you some other examples. And I'm actually not going to do all 4 of these. I'll just do 1 or 2. On the first one, okay, you're kind of asking yourself, what number do I multiply by 3 to get the 12? Well, it's kind of like doing 12 divided by 3, and that's 4. 3 times a 4 equals 12. Can I multiply 11 by 4 and get 44? Yes, we can. That's what that equals. Since you're multiplying both top and bottom by the same value, we know these are proportional. Yes. Okay? But like I said, there's another way to think about this. If they are proportional, their cross products must be equal. So we could cross multiply and see if you get the same thing. If we do 3 times 44, that gives us a total of 132. And if I do the other cross product, 11 times 12, that also equals 132. Since cross products are equal, yes, these are proportional. Okay? Moving on to part B, let's just check the cross products again. Okay, if I cross multiply here and here, 10 times 5 is 50, but 3 times 17 is not 50. 3 times 17 is 51. Those are close but not equal to each other. So no, these are not proportional. Okay? Another thing you could look at, other than doing the cross products, like we said, you could try and find a number that you multiply both top and bottom of one fraction by to equal the other fraction. All right? It's like you're unsimplifying the fraction. All right, one final real-world example here. You're baking a cake that calls for 5 cups of flour, but you only have 3 cups. So if you decide to scale back your recipe to change the amount of flour needed so you can use what you have, how much sugar would you use if it originally called for 2.5 cups? Well, there's a lot of different ways I could do this problem, but in all honesty, the easiest way to do it is using a proportion. I'm going to set up my first ratio. A proportion is 2 equal ratios. My first ratio is going to compare flour to flour. And so I'm going to choose to put the original amount of flour the cake recipe calls for on top, so 5 cups of flour, compared to only 3 cups that I have. So I'm going to use the ratio 5 to 3. That's going to help me determine how to set up the other ratio, which is going to have an x for the amount of sugar I'm going to use. The recipe calls for an original amount of 2.5 cups of sugar. Well, the original amount of flour was 5 cups, which is on top of its fraction. So the 2.5 cups matches and goes on top of its fraction. That is compared to the amount of sugar I'm going to use, x, which is in the same position in its fraction as the 3 cups of sugar I'm going to use, or sorry, 3 cups of flour I'm going to use on the bottom of its fraction. Now we have a proportion, and we cross multiply to solve. 5x is one cross product, and the other one, 3 times 2.5, or 2.5, is 7.5. And now we simply divide by 5. And dividing by 5, we get our x amount for the sugar we're going to use is 1.5 cups of sugar. And that's how you can apply proportions to problem solving. That finishes this video. You should be able to move on to the assignment. Please make sure you message me in Canvas if you have any questions.